So hey guys, today let us see the MCQs for the chapter Electrostatic Potential and Capacitance. Coming to the first question, the ratio of charge to potential of a body is. So we know that the unit for charge is coulomb and the unit for potential is V. So we have to see that which of the following options has the unit as C by V. Whether it is from capacitance, inductance, conductance or resistance, we get to see that capacitance is going to have the following unit C by V, which is going to be the right answer. Moving on to the second question, on moving a charge of 20 coulomb by 2 cm, 2 joule of work is done, then the potential difference between the points is. So we know that the relation between V, W and Q can be given as V is equal to W by Q. So on substituting W as 2 joule and Q as 20 coulomb, we get the answer as 0.1 volt, which is the right answer. Moving on to the third question, electric potential of Earth is taken to be 0 because Earth is a good conductor. That's it. Moving on to the next question, what is the angle between electric field and equipotential surface? The angle is always going to be 90 degrees when it is the angle between electric field and equipotential surface. So the answer is going to be option A. Moving on to the fifth question, capacitance of a capacitor becomes 6 by 7 times its original value if a dielectric slab of thickness T is equal to 2 by 3 times D is introduced in between the plates. So the dielectric constant of the dielectric slab is. So we have to find the dielectric constant K. So let us start solving this. We know that the formula for capacitance is C is equal to A epsilon naught by D. So let us take it as C dash, where C dash is once the dielectric slab has been inserted. So once the dielectric slab has been inserted, the formula for it is A epsilon naught by D minus T times 1 minus 1 by K. Okay, so that is the formula. So now we have to substitute the T value, where T is for thickness, as 2 by 3 times D. So let us do that now. So C dash will become A epsilon naught by D, taking D as common, will get 1 minus 2 by 3 plus 2 by 3 times K, where K is the dielectric constant. Now again we are going to write C dash is equal to C. Since we have already written that C is going to be A epsilon naught by D, we will get C by 1 by 3 plus 2 by 3 times K. Now it has also been given that once the dielectric slab has been inserted, it becomes 7 by 6 times C, where C is the origin value of the capacitance. So now we are going to write 7 by 6 times C is equal to C times C by 1 by 3 plus 2 by 3 times K. So on solving this, we will get the answer where K will become 14 by 11. So the right answer is option A, which is 14 by 11. I hope you understood. Moving on to the next question. A conducting sphere of radius r is given a charge q. The electric potential and the electric field at the center of the sphere respectively are. So we know that the electric potential formula is kq by r. So option A and option D are not at all possible. So let us take a look at the electric field at the center of the sphere. It is always 0 and it cannot be kq by r square. So option C is also eliminated. Hence the right answer is option B. Moving on to the next question. Equipotentials at a great distance form a collection of charges whose total sum is not zero or approximately. Okay, so we should know that the distances are going to be same. Okay, so among spheres, planes, paraboloids and ellipsoids, only spheres can have equal distances. So the right answer is option A, spheres. Moving on to the next question. The electrostatic potential on the surface of a charged conducting sphere is 100 volt. Two statements are made in this regard. S1. At any point inside the sphere, electric intensity is 0. S2. At any point inside the sphere, the electrostatic potential is 100 volt. Which of the following is a correct statement? Okay, so let us take this to be the sphere. So we know that inside a sphere, when electric intensity is going to be 0, then potential is going to be constant. So, on noting from statement 1, at any point inside the sphere, electric intensity is 0. So, it is a true statement. So, we can say that option A is going to be eliminated. Okay. And coming to statement 2, at any point inside the sphere, the electrostatic potential is 100 volt. Like we have seen here, that V is going to stay constant no matter what. So option B is also eliminated since statement 2 is also correct. So now noting from option C and option D, option C states that both the statements are true and S1 is the cause of S2. While option D says that S1 is true, S2 is also true, but the statements are independent. Okay. Now that we see that inside a sphere, only when the electric intensity is going to be 0, we can say that the potential is going to be constant. Okay. So from here, we can say that option C is going to be the right answer, where S1 is the cause of S2 and they are not independent. So option D is eliminated and option C is the right answer. I hope you understood. Thanks for watching.